If I go to the course page, here we have assignment data. Okay, I will save link as I will put it in my working directory. Okay, it's an Excel file. I can open it. Now I have the assets here, all of them, right? For now, I will just select some of them randomly. Yeah, let's select these. 1, 2, 3, 4. What's this one? I will select these 5. Is it 5? Yeah. So then on my keyboard, I would press Ctrl Shift down. Copy, open a new file, paste them here, go back to the file. Now copy the dates and put them here. Okay. Now if you get hashtag, increase the size of the cell, then you see the dates. Now this one, we have some formulas here. This is the formula that I use to collect the data from iCard data stream. But we don't need that, so I will remove it. Okay. Now I will calculate the returns for these assets. I calculate continuous compounding return, ln return, log returns. Okay. So if I take ln of the price at time t divided by the price at time t minus 1, and I multiply it by 100. Then I will just copy and double click on this small box. Then I have the returns for all the assets. Now we said you need to also add the form of range factor models. Okay, the form of range factors. So if I go to Google, search form of range data. Here you have Kenes R French data library. Let's assume that now I just collect the data for developed market, depending on what you have. If you have all of them from European market, use the European market. Okay. So here you see I have developed, European, Japanese, Asia Pacific, North American. 3 factor or 5 factor? 5 factor. I know the first one is monthly, the next one is daily. In my observation, in my data, I have monthly frequency. So I click on the CSV file, it will save it as a zip file, and if I open it, I have a CSV file. Okay. So you remember I told you if you get a CSV file from internet, if you download it and the data is not in column wise, so it's messed up, you click on this A, so it select all first column, go to data, text to column, the limited, next, semicolon, comma, finish. Now I have the data. So I need to match the dates. Here we start from February 1990. My data in form of French, it starts from July 1990. It's okay. I will take that. Let's take the whole. So if I press Ctrl C, if I click here, press Ctrl Shift right, and then down, it will select everything. So I copy them. Now we said it's July 1990. Here I have July 1990. So I should paste them here. See, the dates should match. Here I have July 1990, July 1990. If I go down, here I have September 2024. Here I have September 2024. I will remove the last row. Right click on it, delete. Okay? So now the dates are matched. I will remove this column as well. I don't need it. Okay? So now, one issue that I have here, and you can see it, you can see that the decimal separator here for the form of French data is dot, but in my Excel I have comma. So I need to change that. Okay, otherwise in R we will have a problem. You will get error. So on my keyboard I press Ctrl F. Then it pops up this find and replace window. I go to replace, find what? Dot, replace it with comma. And then I would say replace R. Okay, close. And here I will select these cells, make sure that they are defined as number. And now they are defined as number. So everything looks nice now. So I will select the first row in my returns, Control Shift right, down, Control C, Control N, open a new file, paste them here as numbers, not as formula. So right click, paste as values. Go back to your Excel file. I will go up here. I will copy the names for the form of French factors. Control C and go back to the file. I paste them here. Now I need the names for the assets, right? So if I go up here, I would press Shift, left, left, left here, Control C, and in my data, I paste them as values. Okay. Be careful when you copy these. Sometimes these are links. Okay, you don't want them as links. Just copy as values. Paste them as values. Now we need to have the date. So here I will type in date. Go back to my file. I know we start from this row. July 1990. So I take all of them, Control C, go back and paste the dates as well. But you shouldn't paste as values, you should just paste as Control V. Okay? If you get hashtag, just increase the size, then you see your file. So now I will save this file as CSV in my working directory. I call it data. Here I will change the format, comma delimited, CSV comma delimited. You have this CSV Macintosh, CSV MS-DOS, don't select that, okay? Just CSV comma delimited. And you save it. So now I will go back to my R code, I will go R. So here, instead of this BM size portfolio, we need to use data, okay? So at the moment, I'm not changing anything in the code. I will just run it, see what do I get. I run it, I get error. It's okay. I know I use comma as a decimal separator in my Excel, so I shouldn't use read CSV. I should use read CSV2. That's another function, okay? Then I will run it, see if it works. Again, I got error. That's fine. I will change this separator to semicolon instead of comma. Okay? Then I will run it again. Now it works. I look at the DMOF data. I have 411 months and 12 columns. Let's take a look at the columns. What do we have here? See, I have the first column comes the date, and they are in full date format. So I don't need to change them, okay? Then I have my asset. They come in column 2, 3, 4, 5, and 6, okay? Then I have the form of French factors. Comparing to previous computer lab or previous one that we run, we didn't have these RMW and CMA, so we need to revise that, okay? So first we take the returns. We saw it was from column 2, 3, 4, 5, 6. So here I will change that 7 to 6. Row names of return, you don't need to run that. It was with the other data. I will just set them to data, comma 1, the first column in the data. And here for excess return, again, I will change that to 6. And this 11, it's supposed to be the risk-free rate, okay? I know I have 12 columns, and the 12th column is the risk-free rate. So I change 11 to 12. Right? The dim of the data was 12. You see, you have 12 columns, okay? So now, if I run this, it should go smoothly, no errors. I can create the efficient frontier. This is the weight plot for my efficient frontier. This is my efficient frontier. Maybe it doesn't look really nice, but I can make it better. See here, I say x limit or x lim. It's the limit that you have for x-axis. I set it before, I set it to 4 to 10, depending on what type of efficient frontier I get. But here I see that it only goes until 6. So I can change 10 to 6 and run it again. Now maybe it's a little bit better, okay? This is the efficient frontier. See? Minimum variance portfolio, maximum Sharpe, and individual efficient frontier, and somewhere here we have eco-elevated. Eco-elevated, as I said again, this is not one of the efficient portfolios. So maybe it's not a good investment. But historically, it's actually really difficult to beat. So now I can do the Sharpe portfolio. I have 2 assets, Dow Jones, and what was DKKFXIM? I don't remember. You can check it. But we have like 51%, 48% investment in this. What about minimum variance? Now I have 3 assets, right? Again, I have Dow Jones Industrial, Dow Jones Stocks, and that DKKFXIM. I don't know. Backtesting, of course, we can do that. So you see, everything runs smoothly. I don't get any error, nothing. I can plot my cumulative wealth. See, now I don't get 8,000. Of course, the sample size is smaller. We start from 1990. But still, I see this trend that the Sharpe ratio, the maximum Sharpe, the blue line, it actually has the higher portfolio wealth, and then you have minimum variance, and then you have eco-elevated. But that's fine. As long as you get this blue line, it's the higher Sharpe. You could also add a legend to this plot. I didn't put it in the code, but if you go back to Computer Lab 1, you have an example of a legend. Okay? So you can copy that code and put it here and revise the code a little bit. And make the legend so you know the blue line is for maximum Sharpe. The green line is for minimum variance, and the black line is for eco-elevated portfolio. So now if I go down, I can calculate all these performance measures. I don't have any issue until we have the form of range factor models. Okay? We added 2 more factors. Then it means that I'm estimating 2 more betas, right? So how many rows do we have in this matrix? Is 5. I need to change that to 7, add 2 more rows. Okay? Now here, in your regression model, you need to also add those 2 factors. So I would say plus data, which one? RMW and CMA. Robust minus weak, conservative minus aggressive. Do I need to change anything else here? No. That's fine. I just run it. I didn't get any error. My table, I create that, but the row names here, again, we have to add those 2 factors. So I will copy these ones and say RMW and CMA. Then I will run that as well. And now here I have my table. So if I save it, go to my directory, you see here I have historical return on risky portfolios. Let's take a look at the table. I click on A, go to data, text to column, delimited, finish, and increase the size here, and I will just make it bigger. So you see SR gives me the highest the highest excess return, okay? Minimum variance gives me the lowest standard deviation. That's what I expect to get. I have the Sharpe ratio is the highest for the maximum Sharpe, and it makes sense. Even the Sortino is the highest. And interestingly, now you see the value at risk empirical, they are really close, right? So the Sharpe ratio didn't have high tail risks, but if you take a look at expected shortfall, is actually higher. So we would say minimum variance is performing better in terms of the tail risk measures. We could also look at the Jensen's alpha, equally weighted, and GMV, they have negative alpha, but Sharpe, it has a positive alpha, it's 2%. The market betas, which measures the systematic risk, you can see that they are not close to 1, but they are not bad. It's like 0.84, 0.81, 0.79. That's the sensitivity of this portfolio to the market. And then you have the sensitivity to the risk portfolios, and also R score. Now I don't get like 0.99, right? But of course, they are less well diversified portfolios, and that's okay. Still, the R score are high. It shows the variation of these portfolio returns that are explained by these risk factors. Okay? Easy peasy. You can stop recording.